Hello everyone, welcome back to Diksha Karnataka YouTube channel, and today as expected the most expected numericals part 1. So I was supposed to complete this numericals in one shot, but since I have realized that there are a lot of numericals to cover, so I decided to break it into two parts. First part is going live today and the part 2 will be live on Tuesday. Coming Tuesday will be live for this chapter, this topic, right? So most expected numericals, I know many of you were waiting for this. So if you watch these two videos, your numericals problems will be solved. All the numericals you can still answer by watching this video, right? So without any delay, let's start with today's topic. So first let's see what all we are going to have in this week. So Monday to Saturday's plan is there. Next is obviously if you are currently studying in PU2, then definitely you want to score well in your PU2 exam, because PU2 exam marks not only give you a good rank in KCET exam, but also in future whenever you are going to join somewhere as a job, then they will ask you how much you have scored in your PU2. So if you want to score that well in your PU2, definitely you can consider our paid test series, PU2 Success Blueprint test series. You will get all the subjects covered: physics, chemistry, maths, CS or biology, as well as you will get all the question paper and their video solutions. We are coming live to clear all the doubts that you might have. So everything is only for $599, and if you apply my special code SAM100, you will get this for only $499. So everything is for $499. Just add my code and you will get this only for $499, right? Now how many questions are coming? This is not derivation, sorry, my mistake. This will be numericals. Okay, how many total questions are coming? 4 questions are coming. And how many you have to answer? You have to answer only 2 out of them. So total score is 10 marks. 10 marks is in terms of your 100 marks paper, it is 10%. So 10% of your marks coming from this numerical. So if you are not attempting that, then already you are foregoing your 10% marks, which is not good, right? So you have to at least try to answer 2 questions, if not more, right? So 2 questions should be in your mind. Now for that, what you have to do? Do you have to solve all the chapter numericals, all the questions, all NCERT solutions, or what to do? No, I suggest you have to study only these 4 chapters for numericals. For numericals, not for the entire PU board. All the PU board important chapters, all important topics are already discussed in throughout the Brahmastra series. But for numericals, I suggest these 4 chapters. Out of these 4 chapters, I will cover these 2 chapters today. That's why they are bold and highlighted. And next 2 chapters, alternating current and ray optics, I will cover in my next lecture, part 2 lecture. Right? So these are the very important 2 chapters that we are going to cover. From these 2 chapters, one numerical is guarantee. If you complete follow my lecture in this session, and if you practice them regularly, then definitely you can score one numerical, that is 5 marks. From here, this is little bit tricky. Okay, alternating current, one numerical is guaranteed. From ray optics, mostly you will get one numerical, but sometimes if the question paper level is difficult, you should have at least one option. That's why I gave you ray optics as well. Ray optics and wave optics, there is one chance of coming, one slight chance of wave optics as well, but mostly from ray optics only you will get a question, numerical questions, right? So 3 questions if you practice, then you are sure to get 2 questions, right? So that's why I am giving you 4 chapters. From these 4 chapters, definitely you will get 2 numericals. You will be able to answer 2 numericals. So don't worry, just follow this lecture. Now how many questions we are going to cover? 100 numericals? No, only 10 numericals today and 10 numericals in our next class, right? So only 20 numericals that you have to do. So from each chapter 5 numericals, on an average from 4 chapters 20 numericals that you have to at least know by heart. Okay, if obviously the same numericals will definitely not come, they will change the value, they will change, maybe changing the language, but the heart of the questions will remain same. So electric field will remain electric field, electric potential will remain electric potential. So only thing that how they are asking the questions might change. Okay, so that's why it's few varieties I am solving today, so you have to understand that, right? So you have to realize that what are all the questions that I can answer by solving these questions, right? Now let's start with the first numerical from the chapter electric charges and field. Here we go. 2-point charges of +4 nanocoulomb and +8 nanocoulomb are placed at points A and B respectively, separated by a distance 0.2 meter in air. Find, so this 0.2 meter can they be 20 centimeter. So this 0.2 meter is basically 20 centimeters. So in the exam they might ask you 20 centimeter. So in that case you have to convert it into meters. Okay, 0.2 meters, right? So these are all the different variations that you have to remember. So every unit should be in SI unit. First point of solving the numericals, right? Find the magnitude of the resultant electric field at the midpoint O of the line joining A and B. What will be the magnitude of the resultant electric field at O if +4 nanocoulomb is replaced by another +8 nanocoulomb? So this is the basic question. So first of all, since the question is given in as a description of points, so we have to draw the diagram. Very, very important. So first is point A and next is point B. The distance between them is given 0.2 meters. Okay, this is given. Okay, at point A we have placed +4 nanocoulomb and point B we have placed +8 nanocoulomb. Okay, and they asked you to find the electric field at the point O, which is midpoint of the two between A and B. Now if this is the midpoint, then what is the distance of A from O? What is the distance of B from O? What is the meaning of midpoint? Midpoint means it divides this line into two equal halves, right? So total distance is 0.2 meter. That means this half distance should definitely be 0.1 meter and this half distance will also be 0.1 meter. If you show that in the diagram, you don't need to do anything else. Okay, that teacher will understand. Okay, you have understood the question, you have understood the problem, you have not copied it from somewhere. Okay, so definitely you are safe, right? So this is the basic structure, this is the basic diagram that you have to understand. First time whenever you are solving numericals, try to draw the diagrams. Okay, that will help you a lot. Secondly, if you declare the variables, that is charge at A is +4 nanocoulomb. Plus is not required because if I don't write anything, that by default signifies plus, right? So 4 nanocoulomb is 4 times 10 to the power of -9 coulomb, right? So this is the first thing. Secondly, charge at B is 8 nanocoulomb, that is 8 times 10 to the power of -9 coulomb, right? And distance OA is equal to distance OB, that is equals to 0.1 meter. Clear? So this part, if you write it, it will help you to solve the numericals effectively and efficiently. So first, next what you have to do, you have to know what is the formula for electric field and what is the direction of electric field. These things are important. These are the understanding level. First, these are the given level. These are the all knowledge level. These are all given. Second, you have to understand. So what is electric field? Electric field is force experienced by a unit positive charge, unit positive test charge. Okay, so if you place a unit positive charge here, okay, what will be the direction of force on this charge due to this charge? First we are considering +4 nanocoulomb. Okay, so the direction of force due to plus 4 nanocoulomb will definitely, this is plus, so they will attract or repel. They will repel, definitely. So they will repel means it will be in this direction. This is safe electric field due to charge at A, EA. Now what will be the electric field at O due to say point B? Now in this case again this is positive, okay, and this is also positive, so it will again repel or attract. It will again repel, so repulsion means away from, right? So it will be EB, right? So EA and EB are opposite to each other. So we will calculate the magnitude of EA and EB, and then we will have to subtract, okay? From this, can you tell me which one is greater? Can you tell me which one is greater? A is greater or B is greater? So you see that the charge B is greater than charge A. So definitely EB will be more than EA. So final electric field, the net electric field will be equals to EB minus EA. Even though both the charges are positive, because they are acting in the opposite direction, it will be EB minus EA. This is the understanding part of the solving the question. If you understand this, then you can solve this question. So first, if you draw the diagram, if you mark it properly, then declare the variables properly and understand the question, then you can solve it definitely. Okay, calculation errors can only be solved with more practice. Most students, even though they understand the problem, they suffer from the calculation errors. So you have to overcome that with more and more practice. Now how to do that? First we have to write the formula for electric field. So what is the electric field at A? Electric field is given by KQ by R square. Okay, so here both OA and OB are equal, so I can mark both of them as R. Right, questions generally is not super difficult, not super easy as well, but it is a medium level question, so you can answer that. In case the question paper is hard, then anyway you are not considering numericals, so you can solve at least one numerical. I will tell you the strategy to solve at least one numerical in our next class, but today we have to aim high, that is we have to solve all the numericals, both the numericals, not all numericals, both two numericals we have to solve, right? That is my strategy. So EA is equal to KQA by R square. So what is K? K is Coulomb constant. We know the value. Coulomb constant is 10 to the power of 9. Now if you write that in the bracket that K is equal to 9 into 10 to the power 9, very good. Okay, teacher will be very happy to see that. And if you know the unit, very good. Otherwise you just write SI. That is fine. Okay, if you don't know the unit, you just write it in SI, that is also okay. Now what is QA? QA is this 4 into 10 to the power of minus 9, right? What is R? R is 0.1 meter, so 0.1 whole square. This is the electric field at A due to charge A. Right, now calculate this. 4 9s are 36. This 10 to the power of 9 and 10 to the power of minus 9, they will cancel each other, right? 10 to the power of 9 minus 10 to the power of 9, that is 10 to the power of 0. What is the number to the power 0? Any number to the power 0 is 1. So definitely they will cancel each other. So 36 divided by 0.1 whole square. What is 0.1 whole square? 0.1 whole square is 0.1 into 0.1, that is 0.01. Okay, if you are using calculator to calculate 0.1 whole square, then you are hopeless. If you can answer this without using calculator, then you are good to go. Okay, as I said, always don't use calculator for small calculations. Okay, so 3600 electric field, so it is Newton per Coulomb. Unit is very important. Okay, whenever you are calculating, unit is very important. Without unit you will not get any marks. Something is happening. Yeah, so without unit this is useless, anything can be at 3600, it can be 3600 kilometer, it can be 3600 anything, right? So you have to be careful that what you are talking about here. Now what will be AEB? Okay, EB calculation should be easy. Again, same formula, KQB by R square, that is 9 into 10 to the power of minus 9 into QB is 8, so 8 into 10 to the power of minus 9 divided by 0.1 whole square. So again they will cancel, 8 nines are 72, so you can write this directly, 7200 Newton per Coulomb. Same logic, right? 36 by 0.01 is 3600, so 72 by 0.01 will be 7200. Now what is the net electric field? Net electric field, you already know the formula, that is net electric field will be 7200 minus 3600, okay, equals to 3600 Newton per Coulomb. Very, very important. The unit is very, very important. Now next part of the question is, so sir, you have filled the board. Now what will happen for the next part? Don't worry, next part is simple. What is the next part? Next part says that what will be the magnitude of resultant electric field at O if plus 4 Newton nanocoulomb is replaced by another 8 nanocoulomb charge. So if you replace this with another 8 nanocoulomb, so what will happen? The net electric field, both electric field magnitude wise will be same. Both will be 7200, right? So the net electric field in the second case will be 7200 minus 7200, that is 0 Newton per Coulomb. Okay, so if you replace, if you make both charges equal, okay, then the net electric field will be 0. This is also true if you replace plus 8 nanocoulomb with another plus 4 nanocoulomb. So if both charges are equal, then electric field at the midpoint will be always 0. So be careful while answering this question, right? So let's look into the answer. Answer is 3600 nanocoulomb, Newton per Coulomb, and the other case it is 0. Okay, so 0 part also you have to answer, okay, and you have to answer numerically and with slight line, one line. If you add plus 4, if you replace per plus 4 nanocoulomb with the plus 8 nanocoulomb, then the electric field due to that charge will also be equal to that of the second charge, that is EA will be 7200. Now the net electric field is 7200 minus 7200, that is 0. So this is the part 2. This is part 1, this is part 2. Okay, so if you solve this, you will get full marks. Now let's look into the next question, and all the questions are either taken from your model question paper, previous year question paper, or the model question paper question bank released by your PU board. There is a model question bank, yes, it is released by PU board recently. You can check that out from PU board website. Okay, so they have a lot of difficult questions. If those level of difficult questions comes in your PU board, then most of the students will fail. So I have handpicked few questions which I feel was important for your PU board and can come in your PU board exam. So I have chosen those questions only. Now again, similar questions, but it is slightly difficult. 2 point charges plus 5 microcoulomb and minus 5 microcoulomb. So first of all, first question had both charges positive. Now here we have one charge positive, one charge negative. Okay, are located at A and B, separated by 0.2 meter in vacuum. Again, same 0.2 meter in vacuum. What is the electric field at the midpoint O of the line joining the two charges? So you can see the pattern here. So same pattern, actually last year also similar question came in your final board exam. So that's why I chosen this question. So one charge is, this is point A, point B. The distance between them is again 0.2 meter. Okay, and here we have plus 5 microcoulomb, here we have minus 5 microcoulomb. Okay, again we have to calculate the electric field at the center O. So this distance is 0.1 meter, right? This distance will also be 0.1 meter, right? So these are the 2 points. Now what you have to do, you have to calculate the electric field at the midpoint of the two charges. We will see that if a negative test charge of magnitude 2 nanocoulomb is placed at O, what is the force experienced by the test charge? So this is a new thing. This is a new part that we are going to solve here. Okay, I think if I remember correctly, in 2024 exam, this was given 20 centimeter or 10 centimeter like that. Okay, so the value was given in centimeter, but here for your understanding, for you, your realization, I have kept it as meter. In next few problems we will solve with centimeter units as well, but you have to be careful. If, as I said, if they give you the unit as 20 centimeter, first of all you have to convert it into meter, then you can divide it by 2 to get the actual distance. Right, now let's see. So QA is plus 5 microcoulomb. Now what is microcoulomb means? Micro is not nano. Micro is 10 to the power of minus 6. So be careful. QB is given by minus 5 microcoulomb, that is minus 5 into 10 to the power of minus 6 coulomb. Right, so both charges are given. The distance between them is R equals to OA equals to OB, and both of them equals to 0.1 meter. Okay, so these are the information that is given. Now you have to find the electric field. Now, as I said, whenever you are trying to find electric field, you have to find the directions first. So what is the direction due to plus 5 microcoulomb? So electric field due to plus 5 microcoulomb, say QA, EA, okay, EA will be in this direction. Okay, so this is EA. So I am highlighting with white so that you can understand. So this is EA, this will be in this direction, away from it, right? So how can I find that? If you put a plus charge here, what will be the direction of force? The direction for force will be away from it, right? It will repel it. Repulsion means away from it, right? And if you keep a plus charge here, what will be the force due to minus 5 microcoulomb? The minus 5 charge will attract it, right? So it will be getting attracted here. So EB will be in this direction. So as you can see, in this case, EA and EB both will be in the same direction, right? So the net electric field will be EA plus EB, right? While calculating electric field, the sign of the charge does not matter for calculating the electric field, for calculations, but it matters only for direction. So many students, when they write this formula, EA is equal to KQ by R square, they put the sign over here. Do not put the sign over here. Okay, you just find the direction using the plus charge convention, right? You just find the direction using the charges, but you put only the magnitude here. Only the magnitude is required, nothing else is required. So don't make it complicated. Many students get confused that what to do. For potential, you have to put the sign. For electric field, sign is not required. Now what is K? K is 9 into 10 to the power of 9. Q is 5 microcoulomb, that is 10 to the power of minus 6, and R is 0.1 whole square. Okay, so it will be 5 9s are 45 into 10 to the power of 3, right? 10 to the power of 9, 10 to the power of minus 6, that is 10 to the power of 9 minus 6, that is 10 to the power of 3, right? So 10 to the power of 3, 5 9s are 45. Now what is in the denominator? Denominator, it will be 0.01, so it will go up and it will become 100, right? 1 divided by 0.01 is 100. So 4500 into 10 to the power of 3, that is 4.5 times 10 to the power of 6. Okay, this is a way of writing, and you have to mention the unit. Unit is Newton per Coulomb. Okay, so unit is Newton per Coulomb. Now what will be EB? If you see, EB has the same value. Charges are same. As I said, you have to only put the values. not the sign. See, if you see this equation and this equation, everything is same, so final result will definitely be same. So I can simply write 4.5 into 10 to the power of 6 plus 6 Newton per coulomb. Right, so EA and EB we have calculated. Now what is the net force? So the net force in this case will be EA plus EB. We have already realized that, so it will be 4.5 plus 4.5 into 10 to the power of 6 Newton per coulomb, that is 9 into 10 to the power of 6 Newton per coulomb. So part 1 answer is this. This is the answer for part A. Now how to do the part B solution? So now the part B is saying that if we put a charge of magnitude 2 nanocoulomb at the center, then what will be the force experienced by it? So force experienced, this is the part B, force experienced is basically given by Q into E net. Okay, what is the Q? Q is 2 nanocoulomb. 2 nanocoulomb means 2 into 10 to the power of minus 9. Right, QO, let me write it QO because we are placing that charge at O, so I am denoting it with QO. So 2 into 10 to the power of minus 9 is the charge, and electric field is 9 into 10 to the power of 6. So if you multiply, you will get 18 into 10 to the power of minus 3 Newton. Okay, now whatever form you can answer 0.018 or you can leave your answer here. This is the answer for part B. This is also correct. Let's see the correct answer here. So 9000 Newton per coulomb and 18 into 10 to the power minus 6. So either I have made some mistake or I made 10 to the power of minus 3 extra. Now let's check the answer once more. So answer is 9 into 10 to the power of 6 Newton per coulomb and 18 into 10 to the power minus 3 Newton. Okay, the force unit is not written here, it will be Newton. Okay, so 18 into 10 to the power minus 3 Newton. Unit is very, very important. If you are not writing units, they might deduct some marks from you. Now question number 3, charges of 10 nanocoulomb, minus 20 nanocoulomb, minus 10 nanocoulomb and plus 20 nanocoulomb are placed at the corners of A, B, C and D respectively of a square ABCD of side 0.5 meter. Calculate the resultant force on the charge at D. So let's solve very, very interesting question. So first of all we have, and this question is from question bank, PU board provided, so you can expect this kind of questions, if not for board then for pre-board. So these are these kind of questions are very, very common in pre-board exam. Okay, every time pre-board exams they ask one question, slightly difficult questions from this chapter, so you can expect this question in your pre-board exam. So what is the charges? Plus 10, okay, here minus 20, then we have minus 10 and we have plus 20. Okay, these are the charges. So what you have to do, you have to calculate the force at point D. So let me draw this point D slightly better, okay, so that it does not overlap with anything. So D, and it has a charge of plus 20. Nanocoulomb is common for everything, so we are not writing nanocoulomb. Now what will be the net force at D? So for that, what you have to do, first of all you have to calculate the force due to the individual charges along with their direction, then you have to add them vectorially. That is slightly tricky. So first of all, what you have to do, first you have to find the force due to the plus 10. So plus 10 plus 20. So what is the direction of force? Is it attractive or repulsive? Both charges are positive, that means it is repulsive force, and repulsive force will always be acting in this direction. Right, now this is plus 20, this is minus 10. So what is the force? Repulsive or attractive? Charges are opposite sign, then definitely it is a attractive force. Let me use different colors so that it is easier to understand, right? So this is an attractive force, right? This is an attractive force. So this is EA, this is EA, FA, sorry, this is force due to A, okay, and this is force due to C, and force due to B. Now tell me, what is the direction of force due to B? Is it attractive or repulsive? Charges are of opposite sign. Charges are of opposite sign means definitely it will be an attractive force, right? Attractive force in this direction, and this is the force FB. That is why it is a slightly difficult question, because here you have to deal with three different forces and then you have to find a sum of these three forces, right? So how can we do it effectively? Okay, you can apply polygon law, whatever you can, and add the forces, but first of all you have to apply Coulomb's law to calculate the forces. Okay, so calculate the forces. Let's say FA. According to Coulomb's law, we know that force is basically Q1 Q2 by R square, right? Coulomb's law says that. Now in this case Q1 is our A, point A. So what we will do, we will write QA and here it is QD, right? So we are trying to find force on D due to point A. So this is the first force, right? Now we will put the values. Before that we have to convert the charges. QA is plus 10 nanocoulomb, that is 10 into 10 to the power of minus 9. If you don't do it, you will mess it up and you will final result will be difficult to find, right? You will, because I am using 1020, you will also write 1020 and you will forget to mention that 10 to the power of minus 9. Okay, I have seen that in students, they just use the values without using the proper conversion. So even if they have applied the correct formulas, even if they have at least done some part of the problem correctly, they get 0 marks because they have not done the conversion properly, right? And you do get part marking even if your final answer is incorrect. If you have solved the problems properly, if you have at least solved some steps correctly, numerically correct, then you will get the marks. Even if your final marks is wrong, you can get still up to 4 marks. Final marks generally has only 1 mark, right? If you have solved all the steps correctly. For example, if you calculate FA, FB, FC correctly, you will get 3 marks. For adding them, first you have to add these two charges, that will give you 1 more mark, and final addition 1 more mark, right? So that is why it is slightly tricky. So FA is equal to QA QD by R square. R in this case is this distance, that is the 0.5 meter. It is a square, right? 0.5 meter. So put that value here. What is K? K we know, 9 into 10 to the power of 9. QA is 10 into 10 to the power of minus 9. QD is 20 into 10 to the power of minus 9, and R is 0.05 whole square, right? Now obviously this 10 to the power of 9, one of them will cancel, we can simply cancel them, right? Now what is, let me give you a clear idea about 0.05 whole square. What is this term? 0.05, you can write this as 5 times 10 to the power of minus 2, right? 0.05, that means 2 decimals. 2 decimals is 10 to the power of minus 2, right? We can write it like that. Now if you square this, you will get 25 into 10 to the power of minus 4. Right? So instead of writing this, we will write this as 25 into 10 to the power of minus 4. Okay, now this is a long problem, so we will only keep the final value. So you have to follow my lecture to understand this problem. So 9 into 10 into 20 into 10 to the power of minus 9. Right? Now let's try to cancel whoever can be cancelled. 10, 5 tens are 5 twos are 10, 5 fives are 25, 5 fours are 20. So we are getting a good value. So 8, 2 fours are 8, 8 nines are 72 into 10 to the power of minus 9, and here we have 10 to the power of minus 4 in the division. So in the division 10 to the power of minus 4 means when it goes up it becomes plus 4. So it will become 72 into 10 to the power of minus 5. Right? 72 into 10 to the power of minus 5 Newton, obviously. Okay? Or you can write it as 7.2 into 10 to the power of minus 4 Newton. That is also fine. So this is the first force Fa. So I will erase it. This part I can keep, but I have to erase this part because otherwise the question will overflow. So the first force is 7.2 into 10 to the power of minus 4 Newton. Okay, next is FB. What is FB? FB is K QB, QD is common by R square. R is same because it is a square, right? So sorry, FB we will come back later. Let me calculate FC first. FB is not easy to calculate, obviously. As you can see, it's a diagonal, so we will come back to that. You need to know the slight geometry over here. So we will calculate FC first. Okay, what is FC? FC is again the same distance, that is 0.05. Okay, so we can easily calculate. And if you see in this case, as I said, when you are calculating force also, do not use the sign, only use the magnitude. So if you use the magnitude, you will see this is also has the same magnitude as this. Okay, because this was plus 10, this is minus 10. Plus 10 into 20 divided by this square into K is this value. Here minus 10 into 20 into K divided by 0.05 whole square. So that is also because we are only using the magnitude, the resultant value will be same. Okay, if you write the direction as well, it will be better. It is along AD, it is along AD, here it is along DC, along DC. Okay, that will be perfect. So FA and FC will be equal in magnitude. Right? If you still have any doubt about that, don't forget to mention that in the comment what is your doubt. Or you can pause the video and think for 2 seconds why sir is saying these two will be equal. Same charge pair. Okay, charge pair is same. Sign is different. Because of the sign is different, the direction is different. Okay, that is fine, that I am accepting. But magnitude wise, they will have the same value. Now we have to calculate FB. Okay, to calculate FB, what we need is this distance. Okay, so this distance is R dash. This was our R, this is our R dash. Now what is the relationship between R and R dash? Okay, so this is a, what is this? This is a square. So if this is a square, what is the diagonal of a square? Sir, I forgot the formula. Don't worry. So square, say this is A, this is A, this is a right angle. So what is this? Now forget this. Forget this half. What is this? This is a right angle triangle. So what formula we know about right angle triangle? Sir, I know. Pythagoras theorem. Yes, Pythagoras theorem. So H equals to square root of a square plus a square, that is square root of 2a square, that is square root 2 into a. So R dash is nothing but R root 2. r into root 2, right? So this is the thing that I also recall some concepts. Okay, even if you have forgotten that, how to recall that, how to remember that also I helped you. I hope this will stay with you till you are going to complete your PU board, right? So that is very important to remember. Now what is r here? R is 0.05. So r is 0.05, that means it will be 0.05 times root 2. Okay, generally root 2 comes with a full whole number, but here it is coming with a decimal number, so that's why I have written it like this. Now what will be FB now? Can we write it? K QB QD divided by R dash square, that is 9 into 10 to the power of 9. QB is minus 20. Sorry, as I said, we will not use the sign here because sign is not required to calculate force, only direction matters. So 20 nanocoulomb obviously minus 9. QD is another 20 nanocoulomb, right? That is 20 into 10 to the power of minus 9. Okay, this is cancels, and divided by, we have 0.05 root 2 whole square, right? Now we have to calculate this one. We have already calculated one of them, right? 0.05 whole square. So what was 0.05 whole square? That was coming out to be 25 into 10 to the power of minus 4. Right? Now if you add, instead of that, if you add one more, that is 0.05 square root of 2 whole square. So you have to add square root of 2 whole square. This whole square we have already know, and this one we are doing it. So it will be square root of 2 whole square, that is, it will be only 2. Right? This is only 2. So we have calculated this as well, 25 into 10 to the power of minus 4 into 2. So now we will erase this. So we will just replace it with that value here. 25 into 10 to the power of minus 4 into 2. Now again we will cancel whatever can be cancelled. 4 5s are 20, 5 5s are 25, 4 5s are 20, 2 4s are 2 2s are 4, right? So 2 4s are 8, 8 9s are 72. Oh my god, we are getting the same value no matter what, right? 10 to the power of minus 5, or again 7.2 into 10 to the power of minus 4 Newton per Newton. All the forces, definitely you have to add the unit. So all the forces turns out to be equal. Now this is not the solution. Okay, this is not the final solution. If you simply add them, you will get only 3 marks. If you simply add them, but at least you should know that even if you have calculated up to this point, you still can get 3 marks. Even if the question paper is difficult, you are not able to solve the final question, you have to understand what is required from this problem, and if you solve part of the question, still you can get marks, right? So what is the direction? Direction is along D to B. So direction is along DB. Okay. Now what we have to do? First, we will find 2 perpendicular vectors and we will add them. Why? It is easier for us to add perpendicular vectors. Now in this case, all the vectors are equal. So that is a very important part of this problem. That's why this problem is, even though the concept is difficult, the problem calculation wise is easier. Why so? If you add 2 equal vectors, okay, that angle becomes 45 degrees. That is what important here. Now normally it is not, but because 2 vectors are equal, FA and FC are equal, their solutions, their addition will be 45 degrees. This will be 45, this is also 45, but this angle is not matter, only this angle is matter. So why, we will explain. So say this force is FAC. So what is FAC? When the vectors are perpendicular, their summation, they are to add them, only thing that we have to do is we have to just square them and then square root them. So FA square plus FC square, as easy as that. So that is the basic thing that you have to remember. When two vectors are perpendicular, you can add them using this formula. So what is that? FA square. So basically 10 to the power of minus 4 I can definitely take common, because if you square it and if you take the square root of it, it will be coming out as a constant. Only thing that you have to bother is 7.2 square plus 7.2 square. Okay, now what is 7.2 square and 7.2 square? You don't need to calculate that either, both of them have equal value. So you know one more thing, that a square plus a square square root is basically a root 2, that is 7.2 into root 2 into this value. And as I say, don't put the value of root 2 at this stage, you don't need to. Now why I said this is important, because this is a diagonal of a square, right? So diagonal of a square automatically makes an angle 45 degrees here. This is the resultant of A and C. This is also making an angle 45 degrees, right? So what is the total angle here? 45 plus 45, the total angle is 90 degrees. So the total angle is again 90 degrees. That means again we can apply our old friend formula, that is this. So FACB, that is equals to square root of FAC whole square plus FB whole square, because they are perpendicular. That is why this is an easy problem. Otherwise, if they are not perpendicular, formula is lot difficult to apply and lot difficult to solve. Okay, maybe in JEE you might expect some that kind of questions, but there will be some kind of tricks also. So they will not give you a difficult solving question, but yeah, you might expect something like that. Now anyway, this is not JEE level question, this is easier question. So these two angles are 45 degrees. So these two angles are 45 degrees, means again we will put the same value, that is 10 to the power of minus 4 will be common. Again all the terms have this. Now here we don't have 7.2 into 7.2. Here we have 7.2 square root of 2, that is 7.2 whole square into 2. Square root square of 2 is root 2 square is 2, right? Plus 7.2 square, right? So what you can do, you can imagine 7.2 as x. So x root 2 whole square plus x square square root, right? This is x, this is also x. In your head, these are the some smart calculations, okay? Or what you can do, you can say this is x square into 2 plus x square, right? So what is x square into 2? X square into 2 is basically 2x square, right? X square into 2 is 2x square. 2x square plus x square is what? 2x square plus x square is 3x square. So basically it is x root 3. Right, so this is x root 3. So we have seen how to solve it. So this will be 7.2 root 3 into 10 to the power of minus 4 Newton. Okay, you can put the value of root 3 and you can calculate the exact value. Okay, it will come out to be 12.4 into 10 to the power of minus 4. So at this stage you can use your calculator. You can use it before also if it gives you trouble. You are allowed to use calculator in your PU board, but to train your mind, to train your calculations abilities, to improve your calculative abilities, try to avoid the calculator as much as possible till the end. Right, this will help your brain to develop some cells, some gray cells. Right, now question number 4. two positive charges of 0.2 microcoulomb and 0.8 microcoulomb are placed at a distance of 0.15 meter apart. At what point the line joining them the electric field is 0? So this is also an interesting question. Again, 2 point charges. So these 2 point charges based questions are very common in PU board. So 2 point charges, one is 0.2 microcoulomb, another one is 0.8 microcoulomb. They are placed at a distance 0.15. Now here the distance is different, right? As you can see, this is 0.15 meter. Now what they have said that at what point on the line joining them the electric field is 0. Oh my god, this is completely different level, right? So we have to find electric field at some point, say at point A, okay, where the electric field will be 0. Okay, so here net electric field is 0. What is the meaning of that? Electric field due to A. Electric field due to A, that is EA. What will be the direction? This is a plus charge, right? This is a plus charge. If you keep a plus charge here, EA will be repelling it, right? So electric field will be in this direction. Now what about EB? EB is also positive. So EB will also repel this charge. Now EB's repulsion will be in the opposite direction, right? So if you are considering this point, at this point electric field is 0, that means E net, what is E net? E net is EA minus EB, bigger minus smaller, that we will consider later. But anyway, EA minus EB, but I am saying E net is 0. So E net is 0 means basically at this point EA must be equals to EB. Right? So at this point EA must be equals to EB. Okay, so that is the basic knowledge, basic idea that you have to have when you are solving this question. So EA must be equals to EB. Right? So sometimes this is also called a null point. Okay, now you have to find the distance from say 0.2 microcoulomb. You can find from other one also. Okay, so this distance is x. So you have to mention from where you are calculating. Okay, let the distance from A is x meter. Therefore, distance from B will be 0.15 minus x. So if this distance is x, this one will be 0.15 minus x. Right? Clear? Now what we will do? We will find these electric fields individually. So EA is basically equals to K QA by x square, right? Simply this, as simple as possible. You don't even have to calculate it yet. What is EB? EB is KQB by 0.15 into 0.15 minus x whole square, right? So these are the two equations. Now what is the condition for electric field to be 0? So electric field to be 0, condition is EA must be equals to EB. Okay, so this is the condition for net electric field to be 0 is EA equals to EB. So now put the values of EA. EA is K QA. I have some space in this problem. This problem is shorter. So K QA by x square equals to K QB by 0.515 minus x whole square. Now as you can see, k cancels. Now put the values of qa. What is qa? qa is 0.2 microcoulomb, that is 0.2 into 10 to the power of minus 6 coulomb divided by x square equals to QB. What is QB? QB is 0.8 microcoulomb, that is 0.8 minus 10 to the power minus 6 divided by 0.15 minus x whole square. So they cancels. Now do the cross multiplication. Okay, you have to do the cross multiplication. Before doing the cross multiplication, I like to cancel this point cancels, and this 2 becomes 1 and this 8 becomes 4, right? We can do that. So 2x by say y is equal to x by z. We can cancel this, right? Similarly, what we have done the same thing over here. Okay, decimals, first we remove the decimals, then we have simplified it. Now we can do the cross multiplication. So 0.15 minus x whole square equals to 4x square. Okay, 4x square, or we can write this as 2x whole square. So a square equals to b square. So what is the solution? This can have a equals to plus minus b. Okay, this is the mathematical solution. Physics, unless and until it's very necessary, we do not consider the negative sign. We will start with the positive sign. In case it is not satisfying our criteria, then we will use the negative sign. First we will start with the positive sign only. So 0.15 minus x equals to 2x by taking square root on both sides, right? Or this minus x will go to the other side and become positive. So 0.15 minus equals to 2x plus x, that is 3x. So x is basically 0.15 divided by 3, that is 0.05, right? 0.05. 0.5 is more than 0.15, right? So if you are dividing, you cannot get more. So 0.05 meter is the answer. Let's check the answer. So 0.05 meter from the 0.2 microcoulomb charge. Very, very important. So we have assumed the distance is from plus x. So definitely it will be 0.05 from. So x is 0.05 meter from 2 microcoulomb charge, 0.2 microcoulomb charge. That is very, very important. You have to mention from which charge you are measuring this. Now next question. A conducting sphere of radius 10 centimeter has an unknown charge. Okay, so conducting sphere of radius 10 centimeter has unknown charge. You do not know how much charge is there. If an electric field 20 centimeter from the center of the sphere, so electric field from the center of the sphere, 20 centimeter from the center of the sphere is 1.5 times 10 to the power of 3 Newton per coulomb, then and points radially inward, so electric field is radially inward. Okay, what is the net charge on the sphere? So net charge on the sphere, we have to apply Gauss's law, and from the Gauss's law, electric field you already know due to a conducting sphere, that you can consider this problem to be a point charge q located at the center of the sphere, and you just want to calculate the electric field here. Now inward means, electric field inward means the charge must be negative. Charge must be negative. Okay, why negative? If it is a positive charge, it will be radially outward. For a negative charge, it points inward direction. So that is the main thing that you have to understand. Now what is the question? So distance is 20 centimeter. So distance is 20 centimeter, that is 0.2 meter. Okay, so Charge we do not know, we are trying to find what is the charge. Electric field is given as 1.5 into 10 to the power of 3 Newton per Coulomb. Okay, and we know that electric field is basically given by kq by r square, right? So what is k? K is 9 into 10 to the power of 9, and you have to mention that in the bracket here, value of k. Q is unknown, r is 0.2, right? Now E is given as 1.5 times 10 to the power of 3, that is 9 into 10 to the power of 9q by 0.2 whole square. Now 0.2 whole square, we have already seen that 0.2 is basically 4 into 10 to the power of minus 2. Right, we have already seen that 0.2 whole square means 2 into 10 to the power minus 1 whole square, that is 4 into 10 to the power of minus 2. That we have already seen in case of not in case of 0.2, but in case of 0.1 we have seen, right? So same thing we can apply here. So you can say, okay, it will be 9 by 4 into 10 to the power of 11 q. So this is negative in the denominator, so once it goes to the numerator it becomes positive, so it will getting added to the 9. Now what we have to do, we have to find this q. So cross multiplication, so q equals to 1.5 into 10 to the power of 3. So whatever was the denominator, that will go up in the numerator, and whatever was in the numerator, that will come down in the denominator. Okay, so this is the charge. Very simple problem. Only thing that you have to use a calculator to calculate this value. Okay, so it will be 1.5 means 4, not 4. So it will be 0.5. It will be 3. Okay, so it will be 4 5s are 20, that is 2 by 3 into 10 to the power of minus 8. So it will go up, 11 will go up and it will become 3 minus 11, that is 10 to the power of minus 8. Or you can write this as 20 by 3 into 10 to the power of minus 9. Or it will become 6.67. 20 by 3 is 6.67. 10 by 3 is 3.33. Right? So 20 by 3 is 6.67. You can check the calculator, nanocoulomb. Okay. One more thing is that this charge will be negative. You have to mention that this is negative. Okay, this is negative. Why negative? Because it points radially inward, so charge must be negative, so you have to explain that part. To explain that part, you get 1 mark. Okay, the charge is negative because it is radially inward. This is for the magnitude. So at the end, when after finding the magnitude, you have to write one line, because the field is radially inward, the charge must be negative. So it is answer is minus 6.67 nanocoulomb. Okay. Now next question is from, now we have completed the chapter electric charges and field. Electric potential and capacitance is slightly easier chapter. Questions are slightly easier, but last year question from electric charges came and most students were not able to answer it. So that's why I am giving you focus on electric charges. But 1 year before that, electric potential was a favorite chapter. So from here also you can expect one question. Out of these two chapters, one question definitely will come. And if it is from the electric potential chapter, it is slightly easier mathematically and calculation wise as well. So that's why this will take less time to solve. So let's look into this. Calculate the potential at point P due to a charge of 400 nanocoulomb located 9 centimeter away. Okay, so first part is calculate the potential. So there we have a charge, say at point A, and we are trying to find electric potential at some point P, which is 9 centimeter away. Okay, the charge is 400 nanocoulomb. What is the second part? Second part says that obtain the work done in moving a charge of 2 nanocoulomb from infinity to the point P. So from infinity you are bringing the charge at the point P, that is 2 nanocoulomb, and you have to find the work done. Okay, does the answer depend on the path along which the charge moves? So we will answer one by one. First is part A. So first we will find the electric field. What is electric potential? Sorry, what is electric potential? Electric potential, electric field is written by E, that is kq by r square. Okay, and in this case, since it is a vector quantity, we do not consider the sign of the charge, we only consider the direction. Electric potential, on the other hand, is written by almost same formula, it is R. Now in this case, the sign is important. This is a scalar quantity, so plus and minus matters. Okay, because when you are finding, always electric potential are always calculated by adding it. Okay, whereas electric field can be added, can be subtracted based on the direction of electric field, and sometimes vector addition is also possible. We have seen that. Electric potentials, on the other hand, always added, and the sign is coming only from the sign of the charge. Okay, so electric potential in this case is kq by r, single r, not r square. Okay, k is 9 into 10 to the power of 9. Q is 400 nanocoulomb, that is 400 into 10 to the power of minus 9. And the distance is 9 centimeter, that is 9 into 10 to the power of minus 2 meters. So everything has to be in the SI. So even if you know the formula, most students will miss it here. Okay, so I am giving you a fair warning. So 9 cancels, so this minus 2 will go up and it will become 400 into 10 to the power of 2, that is 4 into 10 to the power of 4 volt. Unit of potential is easy, that is volt. Okay, so we have calculated the potential. Part A is done, as simple as that. Now next is the work done. Calculate the work done to move a charge from infinity to this point. So the work done is basically, work done only depends on the final potential and initial potential. Initial potential is definitely 0, final potential is Q into V minus 0. At infinity, potential energy is always 0. So final potential energy is Q into V, that is the final potential energy. So what is Q? Q is 2 nanocoulomb. Nanocoulomb means minus 9 will definitely be here, and this is 4 into 10 to the power of 4. So it will be 8 into 10 to the power of minus 5 joules. Okay, so this is the work done that you have to do. Work done's unit is joule, so it will be joules. And as you know, it depends only on the initial and final potential, so it is independent of the path. This work done independent of the path, right? This is one you have to careful. So 4 into 10 to the power of 4 volt, 8 into 10 to the power minus 5 joule, and no, it does not depend on the path. Next question. Capacitance of a parallel plate air capacitor is 1 nanofarad and the plates are separated by 2 millimeter. Find the area of each plate of the capacitor. Very interesting question, very simple question actually. So we know that capacitance of a capacitor is given by epsilon naught A by D. So capacitance of a parallel plate capacitor is given by epsilon naught A by D, where epsilon naught value is very, very important to remember. Okay, SI units. This is the SI unit of epsilon naught. Now, we have to put the values over here. So epsilon naught is 8.85 into 10 to the power of minus 12. Area is unknown. And what else? the distance between the plate is 2 millimeters. 2 millimeters means 10 to the power of minus 3, and capacitor is 1 nanofarad. Okay, so these are the values. We have to calculate A. So very simple problem. So A is equal to 1 into 10 to the power of minus 9 into 2 into 10 to the power of minus 3, cross multiply, right, divided by 8.85 into 10 to the power of minus 12. Okay, so if you see minus 9 minus 12, so it will be minus 9 minus 3 is minus 12, oh sorry, so 2 into 10 to the power of minus 12 divided by 8.85 into 10 to the power of minus 12, they cancel each other, so it will be 2 divided by 8.85, that is approximately 1 divided by 4.4, which will be very close to, if you calculate it, the correct answer is 0.225 meter square. So this will be approximately 0.226 meter square. Okay, you can use the calculator at this stage and you can calculate it, right? Now, easy question without using any sweat. Next question. Two charges of plus microcoulomb, again two charges. Two charges of plus 10 microcoulomb and 5 microcoulomb are 12 centimeter apart. Find the work done in bringing the charges 2 centimeter closer. So this is very, very interesting problem. We have two charges, say A and B. Okay, one is plus 10 microcoulomb, another one is plus 5 microcoulomb. Okay, and initial distance is 12 centimeter, right? So initial distance is 12 centimeter. Now you want to bring them closer, so that now they are 2 centimeter closer. So 2 centimeter closer means this distance by which you have moved is 2 centimeter, right? So this is plus 10, this is plus 5. Now what is the new distance now? The new distance will be 12 minus 2, that is 10 centimeter. Okay, so the new distance must be 10 centimeter. So how to solve it? To solve this, you have to find the initial potential energy of the system, say U1, and final potential energy of the system, this is U1, this is U2. Okay, U2. And then you have to find the difference of potential energy, that is delta U is equal to U2 minus U1, right? So what is the formula for potential energy? Formula for potential energy is K Q1 Q2 by R, not R square, K Q1 Q2 by R. Okay, so when I was trying to solve this question before coming to this lecture, okay, I was making the mistake most of you will make, that is I was putting R square here, and I was thinking why the answer is coming so odd. Then I realized, okay, I am making a mistake. So this kind of mistake is very, very common, so don't make such mistakes. So K is 9 into 10 to the power of 9. K is not given here. K you have to remember. Q1 is 10 microcoulomb and Q2 is 5 microcoulomb, and the distance is 12 centimeter. Initial distance is 12 centimeter, right? So now calculate the value. Okay, 3 4s are 12, 3 3s are 9. Okay, 2 5. So it will be 3 into 5 into 5. So 25, 75 divided by 2. 75 divided by 2. Now what is the 10 to the powers? So 10 to the power of 9 minus 6 minus 6. This will go up and it will become plus. It will be 10 to the power of 9 plus 2 minus 12, that is 11 minus 12, that is 10 to the power of minus 1. So it will be 10 to the power of minus 1. So what is the 75 divided by 2? 75 means 37.5. 75 divided by 2 means 37.5, that is, and 10 to the power of minus 1, it will become 3.75. 3.75 joules, that is the initial potential energy. What is the final potential energy? To calculate the final potential energy, again the same formula will be used, only thing is the distance will change. Distance will now be 10 centimeter, right? So U2 is basically K Q1 Q2 by R, again this is nu R. Okay, so K is again 9 into 10 to the power of 9, Q1 is 10 into 10 to the power of minus 6, Q2 is 5 into 10 to the power of minus 6, and R is 10 into 10 to the power of minus 2. This is lot easier. 10 cancels. Okay, 5 9s are 45. Into, if you calculate all the 10 to the power, so you have already calculated in our previous part. So we know that if we calculate all the 10 to the powers, it will be 10 to the power of minus 1. That is, it will be 4.5 joules. So the work done is basically, work done is delta U, that is 4.5 minus 3.75, which will be 0.75, right? If I am not mistaken, this is the answer, right? 0.75 joule is the answer to this question. Interesting question, right? I hope you enjoyed. Another easy question. Here we have, in the following diagram, value of each capacitor equal to 3 microfarad. Find the equivalent capacitance across A, B. So how to do that? Each of them has 3 microfarad. Okay, so mark them, 3 here, 3 here, 3 here, and 3 here. Right, now we have to identify how the capacitors are connected. Easy to do that. So these three, if you forget about this capacitor is creating some problem here. So this capacitor is basically, you can consider they are connected in series, right? If you start here, this I that you have to have. So this is an I that you have to remember, that they are connected in series. So in case of series connection of capacitor, okay, what is the equivalent capacitor? So first we will calculate the one, we have to name them, okay, so that you can, it is easier for you to write. So 1 2 3 4, you have to draw the diagram on your answer sheet, and then you have to name them so that when answering it, it becomes easier for you. Okay, so 1 2 and 3 are connected in series, right? Let the equivalent capacitance is CEQ. Let the equivalent capacitance is CEQ. So we know that, therefore 1 by CEQ equals to 1 by C1 plus 1 by C2 plus 1 by C3. Here we have 3 capacitors all connected in series. So in case of series connection, you have to remember they behave like parallel combination of resistors. Okay, so 1 by 3 plus 1 by 3 plus 1 by 3, that is, if you add them, 3 common, 1 plus 1 plus 1, that is 3 by 3, that is 1, or C equivalent is equal to 1 microfarad. Same unit, right? So first stage is done. Next stage is, now if you see, if you replace it, if you draw an equivalent circuit of this, then you will get like this. Now these three capacitors are replaced with only single capacitor, that is C equivalent, and the 4. Now how they are connected? These two are connected in parallel. So 4 and CEQ are in parallel, right? Therefore C net, the final capacitance C net equals to C4 plus C equivalent. When they are connected in parallel, they just simply gets added. So it will be, what is the value? 4 plus 1, 3 plus 1. Capacitance is 3 microfarad, right? So even though I named it 4, okay, I named it 4, the capacitance for each of them are 3, right? So capacitance for each of them is 3, so I can just simply say 3 plus 1, that is 4 microfarad. This kind of problem is also common in 3 marks question. From this chapter, if a 3 mark numerical question is asked in the 3 mark question section, this kind of questions are very common there, right? So 4 microfarad is the answer. Easy question. Now last question of today's lecture. I know many of you are waiting eagerly. So this is the last question. 2 capacitors of capacitance 2 picofarad and 4 picofarad are connected in parallel across 100 volt supply. What is the total capacitance of the combination? Determine the charge on each capacitor. So what we have to do? 2 capacitors of capacitance 2 picofarad. So say C1 is equal to 2 picofarad, C2 equals to 4 picofarad, connected in parallel. So they are connected in parallel across a 100 volt source. This is the circuit, right? This is the simple circuit and they are connected in parallel with a 100 volt battery, right? What is the total capacitance of the combination? Total capacitance, total capacitance is C equivalent. Then we know that C equivalent is basically C1 plus C2. Why? Because they are connected in parallel combination. So 2 plus 4 equals to 6 picofarad, right? So this is the equivalent capacitance. Now what next? What is the total capacitance of the combination? Determine the charge on each capacitor. Very interesting. Charge on each capacitor. So charge on C1 say Q1, charge on C2 say Q2. You have to write it down anyway. Let the charge on Q1 is charge on C1 is Q1, charge on C2 is Q2. So what we know, in parallel combination, individually every one of them has same voltage, right? That is why charges are different. So Q1 is equal to C1V. What is C1? C1 is 2 picofarad. Picofarad means 10 to the power of minus 12. Okay, and volt is 100. Very interesting, right? So it will be 200 into 10 to the power of minus 12, or you can say 0.2 times 10 to the power of minus 9, or 0.2 nanocoulomb. If you can't do that, you will leave your answer here. That is also fine. Okay, answer will be, in this case, will be coulomb. This is coulomb. This is coulomb. That is also fine. Okay, you will get the full marks. Q2 is equals to C2V, that is 4 into 10 to the power of minus 12 into 100 coulomb, or 0.4 nanocoulomb. Similarly, you can leave the answer 400 into 10 to the minus 12 there. That is also fine. You will get the full marks. No need to worry. So let's see the answer. Answer is 6 picofarad, 0.2 nanocoulomb, 0.4 nanocoulomb, right? So we have completed today's lecture. And if you are also struggling with your PU board preparation, then worry not, we have perfect test series for you, which is PU2 Success Blueprint Test Series. What all you will get? You will get 4 part test. Part tests are already over, but you can download the question paper and solve from the question paper on your own time. The solutions, we will provide you the solution, text-based PDF solution, lecture, video lecture, live solution, as well as physics, chemistry, biology and CS. Everything is covered. Whatever doubts that you might have, we will come live, ask you to clarify all your doubts, right? So everything is available in this, and the price is $599, but till now there is an offer going on. If you apply my code SAM100, you can get this for only $499, right? The link of this is given in the description. And I will be back with part 2 of this video very soon, and please share with your friends, whoever is struggling with numericals, solving numericals. Don't forget to share with them, and subscribe to our channel if you have not yet. I'll be back. Bye.